All right, it's calculus. Got some notes here for remote calculus, but really everyone in general. Here are really the last two sections covering the last two homework sets in chapter 2. We're talking about the limit definition of a derivative as that applies to the tangent line to the curve question and the general derivative using the limit definition. So in the first 6 here, for each function, find the equation of the tangent line to the curve at the given point. We have this curve here. We should know that it's the parabola. 3x squared minus 4x plus 2 at 2 comma 6. So I want to know what's the equation of the tangent line there. What is the rate of change at 2, 6? Here's that formula we're going to need to know, folks. Slope is the limit as x goes to a of f of x minus f of a over x minus a. Again, slope, this is just slope formula here. Difference of the y's over difference of the x's. Just that x, that distance is going to get so very small. So close to 0. All right, so here we go. We got f of x minus f of a. Oh, I made a mistake. Minus f of a. Again, this is a, what you're plugging in for x, and that is f of a. So it's actually minus 6 all over x minus a. And another boo-boo, it's the limit as x goes to 2. Yes, you have to have that in each step. Okay, so scrolling, moving this down a little bit. Here we have the limits as x goes to 2 of 3x squared minus 4x minus 4 divided by x minus 2. And now we need to factor this. We know it's got a factor. We know x minus 2 has got to be one of the factors because we always get this to cancel out. So if you're not good at factoring right now, you know x minus 2 is a factor. Well, if x minus 2 is a factor, x times what gives you 3x squared? That is 3x. A negative 2 times what gives you a negative 4? That is a positive. Ooh, I made a mistake. That's just 3x. But then you get a positive 2 here. You could FOIL it. You'll get exactly that over x minus 2. The x minus 2's will cancel now. So now you have the limits as x goes to 2 of 3x plus 2. We can plug 2 in for x, and you get 8. That's the slope. It takes so much work to get the slope. The equation of the tangent line, remember I told you in Algebra 2, we'd use point slope here, which is y minus the y value. It goes through 2, 6. We know that. Is equal to the slope times x minus the x value. This is your final answer. And really the most important part there is the slope, the rate of change. All right, so that's what we're going to do on the next 5. Coming up. So example 2 here, I'm going to use that same formula. Example 2, let's take a look. Again, I'm pretty much just looking off of a given homework set here. We're going to have f of x is equal to 5x minus 3x squared at, let's go, negative 1. Negative 1 should be negative 8. Again, should be plugging in negative 5 minus 3, check. Okay? So f of x is equal to 5x minus 3x squared at negative 1, negative 8. So the slope is equal to the limit as x goes towards negative 1, the x value, of f of x minus f of a, the y value, over x minus a, minus the negative 1. So you got the limits as x goes to negative 1 of negative 3x squared plus 5x plus 8 divided by x plus 1. So we should notice we don't factor with a negative leading coefficient. So let's take the negative 1 out. 3x squared minus 5x minus 8 over x plus 1. All right, we can see that good. Now we have the limits. As x goes to negative 1, I know x plus 1 is going to be a factor. That's going to leave me with 3x again. X times 3x gives me 3x squared. Positive 1 times a negative 8 gives me negative 8. I know that's the other factor. Again, you can FOIL that out to get this. Gonna cancel the x plus 1. So now we have the limit as x goes to negative 1 of the opposite of 3x minus 8. So now I can plug negative 1 in there. I'm going to get negative 11, but the opposite of it is a positive 11. Positive 11, 0, 0 is the, all right. Let's see, we got 0, 0 in there. All right, plug negative 1, you get 11. All right, so you got y minus the y value. So y minus the negative 8 is y plus 8 is equal to the slope times x minus the x value. X minus the negative 1 is x plus 1. And that is hard to see, and now we can see it. Okay, again, pause this whenever you need to. All right, we're going to go on here to the next one. Example 3. F of x is equal to the opposite of x squared minus 3x plus 5 at, find the equation of the tangent line of that curve at the following. Let's do one where it is positive. We've done a few ones, so let's actually go 2, 2, negative 5, I believe. 2, negative 5. Again, all you got to plug 2 in there. You get negative 4 minus 6. Yeah, plus 5. Very good. All right. So the slope is the limits as x goes to 2 of f of x minus f of a divided by x minus a. So we got a negative x squared minus 3x plus 10 all over x minus 2. Again, I want to get in the habit of factoring out that negative x squared plus 3x minus 10, which factors nicely. X plus 5x minus 2. We know the x minus 2 is going to have to cancel out. The limit as x goes to 2. The opposite, x plus 5x minus 2. All over x minus 2. The x minus 2's cancel. So the slope is going to be the opposite of 2 plus 5, which is a negative 7. That is the slope. That is the slope. So y minus the y value, y minus the negative 5 is y plus 5, is equal to the slope times x minus the x value. All right, let me move that down a little bit and let you see that. And I'm going to give you 2 more special types here. So like a rational function. Example 4. 1, 2, 3. So I'm going to give you a few more types here. F of x is equal to 10 over, let's go 3 plus x and 2, 2. Plug 2 in for x. You get 2 over 5, which is 2. So the slope is the limit as x goes to 2 of f of x minus f of a, f of 2, divided by x minus 2. All right, again, first 2 is a, the second 2 is f of a. So up top here, I'm going to call this, we're going to multiply by 3 plus x over 3 plus x to get that common denominator in that true numerator, as I call it. The limit as x goes to 2 of, this is going to be 10 minus 6, so it's 4, and then minus 2x, 4 minus 2x. This is my true numerator, divided by x minus 2. That is my denominator. So what I'm going to have here is, this is nice, the limit as x goes to 2 of 2 times 2 minus x over 3 plus x. That's my true numerator. And my true denominator is x minus 2. All right, what's going to cancel here is 2 minus x over x minus 2. That's a negative 1. So we have the limits as x goes to 2. This would be negative 2 over 3 plus x. Plug 2 in, you're going to get a negative 2/5, and that is the slope. Okay. Y minus the y value is equal to the slope times x minus the x value. Equation of my tangent line. See one with a root here, number 5. As we roll along here, example 5, I'll get the camera in a better angle for us there. Example 5. F of x is equal, let's give one with a minus. So 7 minus x at negative 2, 3. When I plug a negative 2 in for x, I get 3. And we should be able to see that again. That is f of x is equal to root 7 minus x at negative 2, 3. So the slope is the limit as x approaches negative 2 of f of x minus, I like to put that in parentheses sometimes. I mean, especially if you're negative, put that in parentheses. Not right now, actually. That looks silly. So minus f of a divided by x minus a negative 2. So that's really the limit as x goes to negative 2 of root 7 minus x minus 3. That's the numerator, all over x plus 2. I need to get rid of this root, multiply by the conjugate. That is roots, same root, 7 minus x, but plus 3, over root 7 minus x plus 3. Ooh, announcement time.
Teachers, just so that you are aware, they are going to be setting off the fire alarm a couple times. So it is just a drill.
Oh, great, guys. That won't be inconvenient. Okay, so the limits as x goes to negative 2. I'm not going to edit this, so if you hear it, that's what, folks. I mean, that's how it goes. What we got? We got, first off, let me make sure you plug a negative 2, you get 3. All right, we should be good here. You're going to have 7 minus x, or root times itself, minus 3 times 3 is 9, divided by x plus 2 times root 7 minus x plus 3. All right, so the limit as x goes to negative 2 of, all right, so this is going to be a negative 2 minus x, right? This is a negative 2 minus x. So I'm going to factor out the negative 1, and that's how I'm going to get x plus 2. All right, again, I'm just going to save time here. This is a negative 2 minus x. So if you factor out the negative 1, you get 2 plus x, or x plus 2. I hope we can see that. And that's what we need to cancel. We need an x plus 2's up top. We need them to cancel. So 7 minus x inside the square root plus 3. Then the x plus 2's cancel. All right, so we're going to have the slope is the limits as x approaches negative 2 of a negative 1 over. Very good. over this 7 minus x in the root plus 3. So that's a negative 1 over root 9 plus 3. So that is a negative 1/6. A negative 1/6 is the slope. You got y minus the y value is equal to the slope times x minus a negative 2x plus 2. All right. Let's see if we can get example 6 here before the alarms start going off. Now, example 6 is a pretty important one because we have to use synthetic division. That will happen on occasion here. Example 6. Example 6. F of x is, let's go, 3x to the third minus 4x squared plus 7 at, what would that be, 1/6? 1/6 it is, at 1/6. Okay, so you got the slope is the limit as x goes to 1 of f of x minus f of a, f of a, all over x minus a. And you're like, all right, looking pretty good so far. The limit as x goes to 1 of 3x to the third minus 4x plus 1 divided by x minus 1. Okay, that's an issue. You don't know how that factors. That's to the third power, okay? You know that x minus 1 is a factor just like before. You just don't know what you're going to be left with. So here's what we're going to do, folks. We should use synthetic division. Set x minus 1 equal to 0. If you know that x minus 1 is a factor, you know that x is 1 is a solution. Remember, we put that in the cubby. We write a 3 for 3x to the third, a 0 for 0x squared, a negative 4 for negative 4x, and a 1 for that constant. We did this in Honors Algebra 2, Chapter 6. We're bringing down that 3. We're really doing 3x to the third divided by a single x. We know it's got to be a 3x squared there. And multiply and add. Multiply and add. Multiply and add. 0 is our remainder there, and we knew it had to be 0, so that is good. So now we have divided the x minus 1 away. We now have the limit as x goes to 1 of 3x squared, 1 power less. We did x to the third divided by x, so that is 3x squared. Plus 3x minus 1. That's what we're left with. The x minus 1 got divided out. So now I can plug 3 in for x, and I get 5. That is the slope. So I have y minus the y value is equal to the slope times x minus the x value. And that is really what your homework set 3 is all about there, whether you are in person or remote. Let us talk about a lot that is on homework set 2, and that is the limits definition of a derivative, and that is this. F prime of x is the limit as h goes to 0, this horizontal distance. F of x plus h minus f of x all over h. That's the difference quotient. That's what we did in chapter 1 over and over and over again. All right, so we're getting the general derivative here. So we're going to get the general derivative for the following. So for the following, given f of x, find f prime of x using the limit definition of a derivative. All right, so we're on example 7. We're going to have f of x is, let's just get an interesting one right away. So what's f prime of x? All right, so f prime of x, the derivative of x, is equal to the limits as h goes to 0. Again, this is still, we still have, the slope formula here. This is a y equals, f of x plus h, y equals f of x, difference of y's. This horizontal distance is going to be 0. My difference, between my x's, it's just going to be 0. Like the last one was, x minus a was always going towards 0 there as well. All right, so I've got, oh, no, I made a boo-boo there. That's f of x. I need f of x plus h. So right here where I see x, I need to substitute x plus h, and then continue that. So this is f of x plus h minus f of x divided by h. Okay, so I've got here difference of two roots. I want to break those roots up. I need to multiply by the conjugate, which is the same two roots, but a plus in between. All right. So, I have the limit as h goes to 0 of x plus h minus 3. See first parenthesis, minus x minus 3. And the first root times itself, the second root times itself. Divided by h times x plus h minus 3 in the root plus x minus 3 in the root, which is the limit as x goes to 0. All right, and the x's cancel, the negatives 3 cancel. You're left with a positive h. This is great. Divided by that h, which will cancel. You have x plus h minus 3 in one root plus root x minus 3. All right, so the h's cancel. So now you got the limits as h goes to 0 of 1 over roots x plus h minus 3 plus root x minus 3. Let h be 0. You have root x minus 3 plus root x minus 3. That's two of them at the bottom there. This is your derivative. A lot of work with the limit definition of a derivative. That's a fact. All right, it's gonna be a lot easier here in a few weeks, and we'll get to do that the rest of the year. All right, but I'm gonna put in some work here with the limit definition. Okay, there's a nice sequential order here. Limits leading to derivatives, leading to antiderivatives that we are going to follow. You will have one on your final, whether it's both in the fall and the spring. Find the derivative using the limit definition. All right. Let's talk about number 8 here. F of x is equal to x to the third minus 2x. What is f prime of x? Okay, that cube's gonna take a while. So f prime of x is the limit as x goes to h of f of x plus h, plug in x plus h, minus, parenthesis, I'm going to put bracket here, f of x divided by h. Whoa. All right, so here's what we're going to do. We know that, again, the most efficient and yet still being careful way. If I have something to the third power, again, it is not x to the third plus h to the third. It's x plus h squared times another x plus h. So x plus h squared would be x squared plus the inner product doubled plus h squared times another x plus h minus 2x minus 2h minus x to the third plus 2x divided by h, which is the limit as h goes to 0. All right, so I know it's going to be x to the third. Then what do I have? I have x squared h and 2x squared h. So it sounds like I have 3x squared h. And then I'm going to have an h squared x and 2h squared x. So I'm going to have 3 of the x h squared. And then I'm going to have h to the third. Again, if we don't have that Pascal's triangle memorized, that's what we're going to do. Then what happens, I mean, I'm just going to continue to write everything, even though we can see the negative 2x and the 2x will cancel. This is great. We know anything that doesn't have an h attached to it is gonna cancel. All right, so what is getting this metaphorical x here? All right, x to the third minus x to the third. HQ, no, I didn't mean to do that. I ain't going bye-bye. Minus 2x plus 2x. Okay, so we are left with, bring it on down, 3x squared h plus 3x h squared plus h to the third minus 2h divided by h. Now we're gonna divide everything by h here, and I think we have room. The limit as h goes to 0 of 3x squared plus 3xh plus h squared minus 2. Let h go to 0. That is 3x squared minus 2. Pretty nice answer. A lot of work. Again, you'll be able to do this one in 1.5 seconds. It'd be almost funny to look at how much work it took. You'll be able to do this in 1.5 seconds. Very shortly. But for right now, you got to show your work that way. All right? And we just got 2 more here. Let's look at number 9. F of x is equal to 2x minus 3x squared. Find f prime of x. So f prime of x is, again, the limits as h goes to 0 of f of x plus h. So I'm plugging in x plus h minus f of x so the limit as h goes to 0 of 2x plus 2h minus, again, here's what we're doing in class. That's x squared. It's going to be multiplied by -3. The inner product is xh, double it, 2xh, multiplied by -3. Again, we should be good at algebra. H squared, multiplied by -3, minus 2x plus 3x squared, divided by h, which is the limit as h goes to 0. What cancels? 2x minus 2x. 3x squared minus, or negative 3x squared plus 3x squared. Then we have, I made a mistake here. Why do I have so many of the, I think I should have another, yeah. All right, you guys can see where I made the mistake. And I think I said it correctly, but this one right here, this negative 3x squared, that should be a negative 3h squared. I think I said it correctly. I wrote it wrong. It should be a negative 3h squared. It's that one right there. We said h squared multiplied by -3. Great. So now the 3, and that's a way to check your answer, folks. You know that something without an h can't be left over. So 2h minus 6xh minus 3h squared divided by h. So now we have the limits. So h goes to 0 of 2 minus 6x minus 3h. Let h be 0. 2 minus 6x. 2 minus 6x. Again, these are great notes for everybody to have. Example 10. Last one. F of x is equal to 1 over 3x. Seems innocent enough. Last one. So f prime of x is equal to the limits. What are we at here? Holy cow, I don't think I've made one this long before. The limit as h goes to 0 of 1 over f of x plus h minus f of x divided by h, which equals to the limit as h goes to 0 of, let's leave it like that, honestly. We would have done this in algebra 2. They both have 3's. This one gets x over x, and this one gets x plus h over x plus h. So the common denominator in that true numerator would be 3x, x plus h. The actual denominator is h. And up top, you're going to have x minus x minus h. You're just going to be left with a negative h, because the x's are going to cancel. Okay, show that work if you need to. So the h's here now are going to cancel. This is great. We have the limits as h goes to 0 of a negative 1 over 3x, x plus h. Now we can let h be 0. Negative 1 over 3x squared. All right, I think that's long enough. Goodness, this is Yak Math Videos signing out.